we will solve radical equations. So if you remember the square root method, we have square root of x, or we have x squared. If you square root both sides, we'll get plus and minus square root a. So if the square root cancels out the square, then if we have something square root, we can actually raise that square root to the squared to cancel that out. So this is called the power rule, where you raise both sides by a power to cancel the radical. So the steps to solving equations: 1, you have to isolate the radical on one side. So the radical must be isolated. It can't be a radical plus or minus a value or something times a radical. It has to be isolated. Then you're going to use the power rule to cancel out the radicals. And then you're going to check answers for validity. Typically, you check your answers if you have more than one, because sometimes or more than often one of the answers is going to be false, or give you a or you plug it back in and you cannot get both sides to equal. So usually if you have one answer, you don't necessarily have to check your answer, but it's always nice to. So to start out with examples, we will have square root x plus 3 equals 4. So we have a square root isolated. So we are going to square both sides. So that gets rid of the radical. And 4 squared is 16. You're subtracting the 3, so x equals 13. So 13 plus 3 gives us 16. Square root of 16 is 4. Square root of a minus 2 equals 3. Square both sides. So we get a minus 2 equals 9. Add the 2 over, so a equals 11. Easy enough. Square root of 3x plus 1, and then we're going to add 1 to this, equals x. So we are going to subtract 1 from both sides. Now we have a radical isolated on one side. We are going to square both sides so that we have 3x plus 1 equals x minus 1 squared. Now remember, x minus 1 squared is the same thing as x minus 1 times x minus 1. Foil that out, or if you know the shortcut, it's going to be x squared minus 2x plus 1. You'll get the same result if you foil this out. Now we have a quadratic equation, meaning that we have something squared. So we need to subtract everything over and then we can either factor or use the quadratic formula. This one we can't square root both sides because we'll end up having a square root of x, and then you will have to repeat this whole process again. So we will factor. So x equals 0 or positive 5. Now, I don't know about you, but one of these answers kind of seems fishy. especially since we have two answers. So I'm going to plug in 5. So we'll have square root of 3 times 5 plus 1 equals 5. This will be 15 plus 1, so square root of 16 is 4 plus 1 equals 5. Well, that checks out. Let's look at the 0. 3 times 0 plus 1, add 1 to that, that should equal 0. Well, that's 0. Square root of 1 is 1, but 1 plus 1 equals 0. That does not work out. So our only answer is x equals 5. And see how that one of the answers can be false. It will not work. Okay. Third root of x to the third plus 7 equals 2. Now, this x to the third cannot cancel out with the cubed root because the whole thing that's underneath the radical is the x cubed plus 7. So to get rid of this, we have to cube both sides. So x to the third plus 7 equals 8. We can subtract 7 to both sides. We'll get 1. Now we can cube root, use our square root method, and we get x equals cubed root of 1 is 1. 1 is the answer because we actually have 2 more answers. And I'll show you by using the factoring method. But when you work it straight like this, it's x equals 1. Here, if we subtract the 8 over, we'll get a negative 1. If we go ahead and factor this, x minus 1, x squared, minus x plus 1, we can still see that x minus 1 equals 0, x equals 1. But here, we have nothing. We can't factor this. If we plug this into our quadratic formula, we get negative b plus or minus the square root b squared minus 4ac all over 2a. So we'll get 1 plus or minus the square root of negative 3 over 2. Well, that's actually an imaginary number. In imaginary numbers, yes, they will work for, and they will essentially work for this. It's a little difficult, but we weed out the imaginary values, and we're only looking for the real. So we have 3, see the x to the third, we have 3 answers. However, we were only dealt with 1 answer. That's because the other 2 answers are imaginary. So you don't necessarily have to solve for this by factoring, but if you do, you can see that 2 of your answers are imaginary. Therefore, you need that real number x equals 1. And here, by doing the cubed root of each side, you can still get x equals 1. It kind of weeds the imaginary numbers out automatically. Square root x plus 10 equals x minus 2. Square both sides, so we get x plus 10 equals, and then we're going to FOIL this out. You can FOIL that out, or I know the shortcut. So all this is the first one squared, multiply negative 2 and x, and then take it times 2, and then the last one squared. Subtract x, subtract 10, 0 equals x squared minus 5x minus 6. Now we can factor. And x equals positive 6 or negative 1. Now, we have 2 answers. That's kind of a red flag to is one of these a false answer? So we need to go back to the original problem. Square root of -1 plus 10 equals -1 minus 2. So we'll have square root of 9 equals -3. Square root of 9 is 3, which does not equal -3. So we can weed out that -1. However, 6 square root of 16 does equal +4, so x equals 6. In my mind, -1 would work because the square root of 9 can equal -3. Like, this is true. I would go ahead and accept that -1, but there's something out there that we are using the principal square root when we solve for these. So I'm not sure on that. I am very unsure of that. I'd have to look back into some of my old books to really answer that question. But yes, when we square root, we use the principal square root. Otherwise, I don't see a problem with saying that. Other than, yeah, we use the principal square root. So for all you need to know, x equals 6, and we're done with the problem. 7 cubed root 2x plus 5 equals 21. We're going to divide the 7 off, so we have cubed root of 2x plus 5 equals 3. Cube both sides. And then subtract 5. Divide by 2. So by the time you get to this point, it will be either a linear equation. Sometimes we'll have a quadratic equation to solve, but after you eliminate that radical, you should be able to work the problem like something you have before. This will conclude this video.